Okay, so those are applications of limit laws, and we can simplify our expressions using these limit laws. So here's another one where we can take the limit of 3x over 3, sine of 3x over 3x. We can do a little trick. So we know this fact. Okay, we know that this is an identity, sine x over x. The limit as x goes to 0. This is an established limit. Okay, we should really be using this as identity. So how can we use that fact to do this one? Well, what we can do is we can group that together like that. We can do a let statement, let 3x equal a. So in the end, we can just say, well, I can change this, and as 3x goes to 0, a is going to go to 0. So I can just, let's say, limit as a goes to 0 of sine a over a, well, that's equal to 1. So this must also be equal to 1. Okay, and one way we can think of this is, if we think of the 3x as the length of that red curve, okay, so the length along the arc is the angle, or the x3x value, and this vertical line represents a sine value. Okay, if I want to know the vertical value of this compared to this arc length, well, as it goes to 0, we saw before that those lengths are essentially the same. As we go to 0, this arc straightens out, it looks more straight, and so we would then say it compares to that vertical line in a 1-to-1 ratio. Okay. Now we could also even further generalize this, and we can say this: sine of ax over x. Okay, so this is the limit as x goes to 0. Well, this really is this. So how does this arc length compare to, okay, and kind of imagine what this looks like. As we go close to 0, sine of ax, okay, is going to be this length here. We'll call that ax. And we want to compare that, and there's 3x here. Okay, so there's ax, and this length here would be 1/3 x, or just this length from here to here is equal to x. So how does this ratio compare? Well, this is going to be essentially ax to this vertical line. Okay, so maybe I'll try to be a little bit more clear about this. This purple line compared to the vertical line here is essentially going to be a 1-to-1 ratio as we get closer to 0. And if this is a 1-to-1 ratio, this shorter piece, which is the x in the denominator, should be a 1-to-3 ratio. Okay, so if a was equal to 3, we can just say this would be 3, the sine x, or sine 3x would be 3 to a length of 1 along the x, or 3. And we could generalize this to a and say that this is going to be then equal to a, okay, because this will just be ax, and this is going to be 1 over a ratio to that. So this is going to be 3 times longer. So a times longer than this length. So we end up with this ratio of just a. And we can actually generalize this as well, and we can use this as an identity too, if we want. Okay. Now we can justify this later with some other ways, but this is good to know as an identity, as this one is too. This is just an extension. This one is just an extension of our original identity here. Okay. So doing these next ones, how can we apply this? Well, we can use some limit laws to help us out here. Sine x over x squared. What we can do is this. We can say that this is a limit as x goes to 0 of sine x over x. Well, we know that's equal to 1. And we can say that, combine that with the limit as x goes to 0 of 1 over x. And this would be applying a limit law. We can just split off that denominator in this way. And we can get this. 1 times Well, 1 divided by x, going 1 divided by 0 from the positive side is going to be positive infinity. Okay, so we're going to end up with positive infinity. And if we actually look at this graph looks like this. It's just going to be kind of go in and in like this, and then it's going to shoot off like that. Okay, and then from this side it's going to do the same, and then it's going to shoot off going down like this. Okay, from the negative side it's going to go down. From the positive side, essentially, it's going to be behaving like 1 over x near 0. Okay, in both cases, whether you're going from the negative side or positive side, it's going to be behaving like 1 over x. What about this one here? Well, how can we deal with this one? Now we're squaring it. So this one we can use this limit law. So if I do this, I can take the limit as x goes to 0. It says for positive side, but in fact this one doesn't really matter. And I'm going to do this. I'm going to take sine x over x. And I'm going to take that limit and square it. And that's the same as squaring the numerator and squaring the denominator and finding the limit of that. So this now becomes much easier because I know the limit of sine x over x as x approaches 0. That's going to be equal to 1. That becomes 1 squared. So we end up with a limit of 1. And if we were to graph this again, we can see that that is truly the case. So this one here, as x goes to 0 from the positive side, well, I know that log, I can do this. The limit of, as x goes to 0 from the positive side, of log of x plus 1. And then I can apply the limit as x goes to 0 from the positive side of cos x. Okay, so I can split off that limit in this way. I can apply the limit of the base and limit of the exponent. And limit laws allow me to do this. So as x goes to 0, the base becomes log 1, which is 0. The limit as x goes to 0 of cos is going to be equal to 1. We end up with 0 to the power 1, which is 0. And we could do the same